Hello and welcome. I'm Shadow of Shadow Gaming, bringing you the next programming with Shadow video. In today's lesson, we are going to be using what we've learned in the past few lessons to develop a small program. This program is going to be a calculator. I haven't given it a ton of thought of what I want it to do, but basically I'm going to have it so that it keeps running until you tell it to quit. You'll pick options, add, subtract, multiply, and divide, and give it a number, and it'll keep applying that number to running total accumulator. Then I'm going to play around with what we've learned and maybe even learn just a little more from it. So without further ado, let's go ahead and get started. Control tilde, the terminal. Tilde's in the key beside 1. Let's see. CD. I call it source. Yeah. Alright. So let's make directory calculator. There we go. .NET new console. We can cancel. I didn't change to the RM program RM source. Got a little bit of lag happening. A lot of lag happening. A lot of lag. Okay, so now let's do .NET. Alright, now we've created our program. Let's do code dot and let's open this code there. And we'll begin. Alright. Program here. Alright. So to begin with, let's do accumulator. Oh, as I'm saying this, there may consider seeing what if you can put together something as well, but I'm not going to give any what I'm thinking, just what I've already said, but you can see what you can put together. Yeah, see how it compares, see if there's things you like better of your design than mine. It's very possible. Programming, you can do things a lot of different ways. So what I'm going to start with here is a long. Reason for that is the length of an int that's another thing. I'm not going to support decimal. The length of an int's only about 2 billion. And I'm actually going to limit it a little later if we have time. So maybe if it'll run. Maybe not. But yeah, I have some pretty decent lag today. Very high lag. There we go. So that's 2,147,000,000 range. Long max value, on the other hand, is a lot bigger. Let's just copy that line. It's longer than I actually intend. I thought was the limit maybe around 1 trillion. We'll talk about the reasoning for that. Yeah, see, it's so much bigger. I'm going to use long as the value here. From a user's perspective, they won't really be able to tell. I'm going to start here with my accumulator. So the idea with the accumulator is it's my running total. What I start with or what I go with. So my thought here is, though, I want to keep in a session. So I want to keep doing the same thing until I tell it to stop. Let's think of how we would do that. A couple ways. We could have a we could actually have a loop here while do while input doesn't equal something like that. So then we could do input input. So we could do something like this, and then do input equals console.read live. Now until it equals quit, it would just keep running. Maybe. There we go. So we could do something like that if we wanted to. I'm going to go to another route. I'm going to go open a notepad. I'm going to do something like this. Running total equals 0. At the so something like maybe a menu. Add equals 1. Maybe something like that. And then final one. I'm going to do 0, but do something like that, and then as we go through, we can just keep doing those operations. I think that would work. We could also do it so that we can say what we want. Like do a plus or a minus or a multiply or a. We could do that route as well. Might do both. We'll see how long it. That's sort of what I'm thinking. And as you go, you're updating the running total. Let's try that first. So to do a menu, what I would actually do instead is do a switch on input. Case input equals 1. Break. So case the input equals 2. I think we talked about switch case statements. I don't remember. Basically, if we didn't, it's basically a fancy if else. Each one of these cases would falls into that. So here, what this is saying is if this input, which we haven't done yet, but if input dot gets console dot read line, if they enter a 1, it was this and does whatever's in here, which right now is not applied stuff here. It's 2, it's this. If it's 3, it's 3. You have to include the breaks, otherwise it doesn't work. 4. Case 0. Break. Now, if they enter something else, there's also a default case. I know I've got a break. I'll add that. There's a basic starting point here. So let's do a little more. See, console dot write line. Do it outside of this loop. All right, so let's see. The little total going on. I think I'm just going to do the menu just like I should. Total route line. Let's do your selection. Add a. I'm going to add a control character here. The control character is led by a slash or backslash here. Slash. This is a backslash. And then whatever the character is, in this case T. T stands for tab. So I don't forget. I'm going to copy this line, paste, do subtract. We'll worry about cleaning up here in a moment. Multiply. We also have one more one for X. Exit. Like I said, I'm going to use 0 for exit. There we go. Now it'll print all these. Let's do one more console.write line. This will give us an extra line in between. No need for that. No need for that either. Alright, so now we'll have an extra line, and now down here, let's do an interpolated string. So interpolated string lets us put stuff out of it. Let's do total and on the next line, let's do console.write line. Let's do write. Make. Let's do select operation. So the reason I went with write instead of write line is I want the input here to be on the same line as it'll show up after the quote here. Right now this is doing nothing, so we'll still exit with it. But let's see how the menu looks. See if it looks anything like I'm thinking. It may not, like I said, I haven't actually done this yet. I'm just thinking as I go how I want it. See, that sort of looks like what I want. Then as you do an operation, you'll do something, it'll do whatever the operation is. It would add the add for in that case. We could still use quit if we want, but I don't want to use quit, so let's hook it up first. Let's do something here. Let's default here. Copy this. Say if you don't give me an option, I'll tell you the help again. Does this. Here's a trick. Apparently I don't know how to do it. There we go. Okay, so it's all four of them. So Shift Control Alt, and then down arrow lets you make a cursor on multiple lines. Then you can just hit Tab and you can use that really nicely. Each editor if you're using a different editor, it may be slightly different. This one's apparently Shift Control and Alt All. You can use that too. Found the default case though, so this is you run. Maybe you run, they don't get anything. It tells them their options. I think that's a good user feature. Let's hit the exit. let's do it like this. So I don't know if I'm going to need this yet, so we may end up removing this, but let's add a full continue loop. We're just going to set this to false here. I may want this, but I may not either. Now this will break us out. Now when that's false there, because they entered 0, it'll quit. So I don't necessarily mind so let's mind if they actually type quit though, because it won't matter for anything else. So we can actually do that with right now. All of these, they hit the break and they're done. You can do those. You can layer case statements. Case quit. Let's do this. Let's do input. So right now there's a little problem. Let's input up to lower. That's going to make it, whatever input is to be lowercase. That'll handle both. We type any version of quit now. Now it'll fall through. Quit. There we go. So actually, don't mind that. And we could have that in other documentation. I'm not going to write other documentation, but we could if we want. Look here, when it's running, we're getting some warnings though, saying that they don't have to put in something here, and theoretically that's true. There's a way to get around this, but for our intents and purposes, I'm not going to worry about this right now. Instead, I'm going to do question. So this says, if this is null, do something else. We're going to do something we haven't seen before, but I'm going to do throw. Let's not do that. Let's do environment.exit. I don't like that. Yeah, let's not do that. So what this is going to do is, if this is null, it's going to exit. But let's adjust. Let's do it a little slightly different. Let's do if input. So there's another way to do this. I'm not going to talk about it, but there's another way. There's a better way. This will work fine, and this is what you'll see in older code. If input is null, do right line. Input should not be read. Quitting. So we could just skip here if we wanted to. That would work as well. I'm going to say if it's null, there's a problem, but we can't address. Don't want to address it here. So instead, we're going to do this, and then let's just break. So this here is as if this is null. Write this and break. Break out of this loop. And I'm not going to be able to test that. I don't have the conditions accessible to me. That's what it would do. So let's add something. Let me add one more thing here. Let's do a case. That'll make it easier here for testing here in a minute. This case is the add case. Let's make this more. Let's say same thing. If they wanted to be more explicit, they could do add as well. Here, case, subtract. I'm going to do sub as well. Again, if you had actual documentation, you could give them that and tell them that. I'm not going to put it in the input. This is going to be a bonus for now. Case, multiply, case, divide. just a little extra functionality just in case, but the intended ways to use the number. Let's add some fun. So here, so add's easy. So whatever we have that number up there, we can add to it for now. Accumulator plus equals what? So in this case, we're going to do long dot by parse right. That's a parse. Let's change this to let's do var equals number. So there's something that should work, I think. And messed up this text, which I may have. I think one will work here, but oh yeah, of course I missed it. Okay, yeah. I need to actually, yeah, okay, yeah. Yeah, I'm not clearly not considering it. Let's do console.writeLine. So the issue is that I need to actually do something to the running total. We out. Let's do it like, let's say equals accumulator plus top thing. Notice we're not in the quotes. Quote. Now we don't need to put here. We want to do readline. Let's see if this does what I want now. So the idea here is print out the running total, and we'll do plus whatever they add. That'll make it show up here in the instead of running total, maybe I just want to say total. We'll adjust that in. Let's do quit. Let's try again. Recompile. Go. That warning. On 8. Oh. Here, when we can fix this. Let's type a quit again. So this one's saying that this type here is wrong. So what's it saying is it can be string or null, and it knows how to handle this as working, but it is giving me that warning. Fix that warning. All you have to do is come here and add a quote or a question mark here. So that says input can now be either string or null. That's exactly the case we're getting here when we. That should address the warning, and we're addressing the condition here that causes the problems. Let's see if that got rid of our warning. It did. There we go. No warning. Let's do an add. I did it right. Let's do a quit again. We'll see. So let's do a. Go ahead and get this right before we keep going. Operation add. Let's add 7. Now the running total is 7. Add again. Add a 9. 16. Yeah, there we go. So I think I like that. So the one problem now, we let's say we add something that's not a number. Let's add an. Nothing happens. Another warning. Nothing. that all right? Maybe. Let's instead of doing that though, let's do a check here. What I want to do is while this, not this. Right line. The add in must be a right. I may not try again there, but we'll do it for now. Like all of a sudden this looks like a do while again though, but it's not. The reason we can't do it as a do while is I want to have the error message. Now let's see what happens. Quit. We were still running. Or does not exist. Let's do long number. Do it like that. A B. There we go. So yeah, so I like that, and that seems to be about the effect I want. So let's try another one. Try to subtract. So what we're going to find is it's going to be very similar to this. So let's copy and paste. So not even sure if it's right. Put this. Googling. I think I got it. Continuing minus the subtrahend. Let's do a minus here. And a minus equals here. That brings us to another point though. Let's add another case. Case plus. So in reality, we'd want to make sure we test all these. These are going to work as long as I'm following the same pattern. Add these. I don't have an easy way to get a division symbol, so we're going to ignore it. I think this will be all we need for subtraction. Let's try. Run. Error. First. No, it doesn't. Pull it out. Put it here. That spacing. Try that again. There we go. Let's subtract. Need to just count. So this is a subtract 4. Now we're running total. That. Now we have a subtraction as well. Let's go ahead and do multiply. Multiply will be the same actually. I don't think there'll be almost any changes except values there. So go ahead and make adjustment. I'm going to use it here. just a factor. Factor that. There, I think we have multiply. While we're at it, let's just divide. There's a problem. So the problem is, what if we divide by 0? We need to check that. Yeah, we're gonna need to do this slightly. Let's not worry about it just for a moment. What's divisor? That may not be the right term. This is all right. So let's do a division by 0. We're going to get an error. Make sure we haven't made other errors here. 4, 0. Handled except. That's telling you you just can't divide by 0. It's undefined. Let's do some. Let's add some logic for this. Oh, this is the or do division input using var. Let's use long. Go. Division input. While division input parses, or division input equals 0. It needs to be a string 0. Must be a non-zero integer. Again. Now I think that'll handle us. Let's see. It'll either, well, we need to update. Let's update here. There we go. So now I think work. Error. Let's check the error here and just again. Multiply. Well, anything by 0 is not all that interesting. Let's do this. Let's try one thing. We do about -1. Okay. What if then let's add something. So let's add a 9. Now let's multiply by 9 times 7 is 63. Okay. There's roughly what we want to see. So what's happening here now is when we do the division, read the input, check if the input's a number, and if not, we're done. Or if it's 0, done. Either of them conditions is false. They're both false. Do this. Must be a non-zero integer. Try again and try it again. That handles the division by 0 since it's undefined, and we can do that. There, we got all populations. Only 94 lines to So here we had a error condition to a closing. There we go, just to have an end of operation. So there, that's roughly what we want. Let's look at an issue. First, we do this twice. There's some other stuff we do twice. We do this in particular. It would be nice if we could do something. In reality, we can. Let's do a return. That says you're done with this main part of the program here. So let's learn about something new. This is called a local method. The idea here is it's something that it's happening inside, and it gives you a way to put parts of it out, put parts of a program and do it multiple times. In this case, it's called modularity, so you can break out a module and then use it elsewhere. In this case, we're going to do void. That's something I haven't seen before. It says this module doesn't actually return anything. What we're going to do instead, just do the console write lines inside. Let's do void print. So that's the general format. So this is the name we would use. And the parentheses here indicate it can give it input and it can do something without. We're not going to do that. Instead, let's come up here and let's copy. Print help. That's how we would call it. So let's here and here. Select all on tab. Do a print help here as well. If you leave off the parentheses, it should give us a compile error. I occasionally see that happening there. Only assignment, calls, increments, decrements, awaits, and new object expressions can be used as a statement. The issue here is you just forgot the parentheses. That happens occasionally. This warning is this is telling us to be null again, so do that. That should have taken care of both of them. There we go. Now if we ask for help, we don't enter anything wrong. That looks like what I want. So there we've just learned something new. We've learned method. So you can think of this like in math you've done in functions. So function usually takes in an input and has output. This one just so happens to not actually take any input. It always does the same output. In other languages, you'll hear these called functions. I would personally say this is a function itself, but C# terminology, it's actually a local method. Let's do another. So this here looks very similar to everywhere except let's do a more complex method. This method is going to do some logic inside. Let's come up here and copy this. So I'm thinking for this method, let's call this. So this one's going to not be void, so it's going to return a long. So that just tells you what it's going to give you back. Long to validate input. We'll ignore what's in parentheses just a moment. Let's put this here and let's see. What do we need? We need looks like a string, and we could do it as a string if we want. Let's do it as a car. say operation. What else do we need? We need the accumulator value. Long accumulator value. I'm not going to use the same. We can. So let's just do that. So this is actually going to be fine because this exists up here at the start, so it actually knows it exists. I personally don't like using it like this, but I actually do see it more commonly like that, so I'll go ahead and stick that out. Do we use number anywhere? We're going to get whatever value we do back, so copy this one. I don't think we need it on the here anymore. And at the bottom, we'll do a return number. So that says, or give me back, I call this, give me whatever this number. Operation. What else do we need? The other thing that changes besides this plus is whatever it says here in the menu. Let's do a string message. Let's replace this with message. There, I think this will do what we want. Need to change the operation. There. Let's see how this works. So this is saying when we call this, we'll give you an operation, which will be like a plus or a minus, and we'll give you a message. I may want to flip. Let's see. No, let's keep it the other way. Let's do it that way. This will say, okay, give me a plus sign, and then let's do it like that. So it says, give me those two. Then what will happen on the inside, I'll create a number, write out a message here and tell you what I'm doing. And I'll prompt the user for input. That doesn't work here for. If we can't. I think we can. Just do it all like that. String user input console.readline. We're not going to be able to do division because it does have this. So division is going to have to be separate actually. We can still use this if we want. Like we could, this would be perfect. Fine. And you could do it, there's ways you could do it with the operation, but let's keep it simple and not do it and do it like. I'm not going to be able to do this for division, but it works for everything else. So let's make sure that's actually. Here. Do long product. No. Factor. Validate input. Passing in. Did it as a car. So X. And string is. Just copy this. There we go. Now it reduced all this code here. So we can say factor. I think here. Long. And validate input. And this here. There we go. A good rule of thumb here is if you do stuff 3 times, that's usually a good sign that it's probably good to pull it out into a method. And is that even the right? Yeah, it looks like equals plus here. Now, and we could do this all in one line. This is exactly the same thing as I had before. And you don't have to tell it what you're doing. There's reasons you might want it to do that. If you're using a debugger, I would say this one's probably better. I'm not using a debugger right now, so we'll do this. Who knows, we may regret it. Let's see. Quit. .NET Run. So now we add a 1. 7 multiply by 6, 42. Now let's add 0. All right, let's divide by 2. 21. Subtract 7. Now let's add again. Add 33. And everything looks like we're working. So it's our validate input. So we pulled out everything except divide. And divide's a little trickier because of this. We could adjust that though if we wanted to. So what you could do there instead is you could here inside you could, instead of going this route, you could check if it's a division, and if it is, check if it's a 0. I'm gonna go making this more complicated and say that's fine. That one's different. We had 3 of the others, so that's good enough to me. And then I think we have everything I wanted to accomplish in this. Let's do a program review quick. So to begin with, we declare some variables here. One new one we learned was this here. Question mark indicates that this is a nullable string. If you're in Visual Studio, if you hovered over it might even tell you that. I remember if it still does that or not. It might tell you that. So this says it can either be a string or it can be a null. We use that to our advantage. So the next line here is this. Call a method. Okay. User call a local method. It actually is. Call a local method. So we learned a little. I won't say we learned, but we at least seen now an example of a local method. And what a local method is that you pull out the information and use it multiple times without like this. Like we pulled out print help and we can use it in 2 places. And it does the same thing. Was it shorter than what we did? No. It was roughly, this is maybe even a little longer than we did. Is it better though? I would argue that it is, because using the local method, we don't have to write this print help each time. Like down here, we don't have to print help again. And that means if we need to add a new one, we just add it down here once. Like say we had some new operation as a 5, we could just add 5 here and we're done. I would say that's a little better in my opinion. It's more modular, so we more divided out, more in chunks. I would say it's probably a good thing. There's some other problems with it. We'll learn later about testing. This would not be testable. We can make it testable though, but it is not right at the That's a local method for print help though. Then we enter the program loop. So add that. That's a thing you might see occasionally. The idea here is this is what the main portion of the program does is the program loop. In this case, it's doing all a great big switch case statement. Let's not get ahead of ourselves though. So then we give the running total and then ask for a operation. The operation is like plus or minus or add or subtract. In this case, we have a menu here, but we also added some shortcuts. We added this if here because we get a compiler warning. What it's saying is that this can be null, or it comes back from readline. In reality, there's a special keystroke you have to do to add that. You can look that up in Microsoft documentation if you would like. But how to handle it, right now I just chose to, if we get a null, we say input could not be read, quitting, and then we quit out of the program. That seems sufficient to me because you had to try to get into that situation usually. There's ways to do it without that, but that's the most common thing I would think of. So then, or another variable. Make an adjustment. Move that and down here. Let's add. Let's do long. Do it like that. Let's make sure it still works. We'll continue our revision there. It does not exist. Try one more time. Actually, copy it through. There we go. So add 24. Now let's divide by 0. Good. Divide by 2. Divide by 1. Divide by 2. Yeah, so it seems to be mostly working. There's something we would do, like if we do instead of 12, let's do divide by 7. Right here, this is going to be odd. It's going to be 1. What's happening there is we're only considering the integer portion of it. The remainder goes away. We could address that, but right now we're not dealing with the remainder, so we'll ignore it for now. Yeah, we could make that adjustment. Yeah, we're about out of time, but we can make that adjustment here. It wouldn't be that hard. Here, this. It'd be a little harder. It's not how I've set it up. What you could do is you could do a modulo. So that's the mod here, and you change how you're outputting this, and then make it say 1 remainder 5, something like that. It would be more changes than I have time for right at the moment, so we'll say that good enough there and turn there. But yeah, so we have a great big switch statement here, and switch on lower so we could add shortcuts here for add, right? What have you. Basically, the menu options, you enter one of these, tries this one, it tries each of them, and if it matches one of them, it just keeps following through until it finds break. In this case, it we did an add, we would say, okay, do this, this, here's something, do this. And it seems like it wouldn't be nice, but it's actually here the on the inside. It actually is a little nicer and can actually be really quick. So then to input that or to actually do the operation, though, we just say is it a bug? Not a bug. Okay. So we take the accumulator and we add whatever validate input returns. The validate input's also a local method. It takes an operation, which is just a symbol we're giving them. I'm hard coding this. We should pull this out into a variable probably, but for this example, this is readable enough to me enough for me, and it shouldn't change. And then add in must be an integer, so the message. So we pass that. This local method returns a long. We add that. Do option for interesting. So in like Rider or Visual Studio, you could press F12 here or something and go to the definition. Doesn't seem to let me, so maybe that's not an option. Maybe I need to C# extend. Validate input. What we do is we take in the operation and the message. We do some work here. We declare a variable, tell them what running total is. The accumulator here is special. The local method has access to what the outside method, the parent method, actually knows about. The parent method has an accumulator, so we just pass that in here. So we could do that here. I've seen it both ways. I've seen it with or without parameters here, so I don't know if that matters. That's what these are called, are parameters. This is how I would do it personally, though. Here we tell them what we're doing, get their input, and we say while it's not a valid number, write out the message. Again, we keep doing that. Eventually, they enter a number, and we return that number. Then they can use it up here to add or multiply or subtract. The division gets a little special because of this. So division by 0 is undefined, as we know. So rather than let it just crash, we handle it here. We say if it's a 0, that's invalid, and try again. Finally, we have a little quit down here, and thought I might do something more with this. Basically, if I had a little more time, there's something else I wouldn't mind doing here. Here with the output just a little more. But also, another way to expand it is right now I can support very large numbers, but if we get so large, let's do eventually we'll get it big enough that it'll just fit. But if it's too large, that's a problem. And TryParse there can't figure it out. We could artificially limit that. I was thinking maybe try to trillion, and we could do it like that. We're out of time, so we'll say that's good enough for now. And maybe in the future we could look at addressing that if we wanted to. I don't know if we want to, though. I actually sort of I'm actually happy with that handling. Like, there's problems like if we could eventually loop over this and get too large. Do again. There we go. Eventually we get so large, and what ends up happening is it loops around and goes negative on us. That's not what we'd want to actually limit that. Like I said, my thought would be just to limit it, say trillions as high as you get, be a quadrillion, but you could do it other ways as well. I'm going to say that this is good enough, though, and say that, so in summary, what we've we've looked at today. We've primarily what we've looked at is using what we've learned before. We've used some of the constructs we may or may not have seen. I think I did in case statements. If I didn't, this was a good example of how you could use one. Because if you did this with if else, this would be a huge if else statement. A large switch case, but it's much smaller than the if statement that match. We've also seen a do while. We've seen input validation. We've seen local methods. That's brand new. We'll learn more about methods here very shortly, but at least now seeing the format of one. It has a return type, as a name, and it has parameters, and then it has what it does inside of braces. And that's pretty much, that's all we've learned. We've seen a nullable string. You can have nullable other types as well, like Boolean can be true or false, but if you make it a nullable Boolean, it can be true, false, or null. Occasionally you have uses for that, and you'll probably see them in later projects later. That's about what we wanted to see, and I'd say this is a fully functional calculator. Like, you could use this, there's an upper limit, but for lower stuff it'd be fine. Did it himself, and my solution here we're about 95 lines. Like, we could do better. This might be hard to remember what we could do, what it's doing, so we might could even split this out more, or add some comments, stuff to make this cleaner. But I am actually satisfied with what I was able to do in this hour. So next time we could look at this again, but instead we're gonna forego that, and instead we're going to look at strings. So we've used strings here a little bit, and I haven't really talked about them, but I've used stuff like to-lower and to-upper already. We're going to look at strings a little more closely the next time. They aren't exactly the same as this long here or this bool here. String here, even though highlighting's the same, it can get treated a little. We're going to look more into that next time. That's setting us up for the lesson after that, but we'll get there next time. Thanks for watching, and have a wonderful day.